Hello, in this video we will learn about the different states of matter. Let's quickly review what matter is. Matter is what the universe is made of. Everything around us is made of matter, including living things and non-living things. What is matter made of? Matter is made up of particles which are in continual random motion. We all are familiar with the common states of matter, namely solids, liquids, and gases. The states of matter are also called phases of matter, so you may hear this term interchangeably. States of matter is the same as phases of matter. Why does matter exist in different states or phases? This depends on difference in the energy of particles and the distance between particles. There is another state of matter which is not commonly known. This state of matter is called the plasma state of matter. You will learn more about the state of matter in your higher classes. For now, just know that there is another state of matter called plasma. This state does not exist on Earth, but this is a very common state of matter in other parts of the universe. If we were to look at matter under a very strong and powerful microscope, we would be able to see the particles that make up solids, liquids, and gases. These particles are arranged in a specific fashion for each state of matter. The distance between the particles in each state of matter is known by a term which is called the intermolecular distance. This intermolecular distance is very small for solids. In liquids, the intermolecular distance is a little more, whereas in gases, the intermolecular distance is maximum. Notice that in solids, the intermolecular distance is very less. The particles are very tightly packed and they have very little space to move around. So in a solid, each particle just vibrates, which means moves back and forth, up and down in a very limited amount of space. In liquids, there is a little more distance between the particles, so they can slide past each other and move around a little more as compared to solids. In gases, however, the intermolecular distance is very large. There is a lot of space for each particle to move around, and the gas particles can move around very freely. And they would take up as much space as is available. Let's look at some properties of each state of matter. We already learned that in solids, the molecules are very tightly packed. This gives solids a definite shape and a definite volume. In liquids, since the molecules can slide past each other, liquids do not have a definite shape. What that means is a liquid can take the shape of the container into which it's poured. So if you have a box of juice, if you pour the juice into a round shaped container, it will take the shape of the round container. If you put this liquid into a square container, it would take the shape of the square container, and so forth. But liquids do have definite volume. No matter whether you pour this juice into a square container or a circular container or any other shape, the amount of liquid, the amount of space it occupies stays the same. In gases, we saw that the molecules move very freely. They have a lot of space to move around. So gases do not have a definite shape and they do not have any definite volume. They will take up as much space as they possibly can. We can change the state of matter by giving or taking away heat. What this simply means is matter can change state based on the amount of energy available to its particles. If I heat up a solid, each particle of the solid, when it gets more energy, can start moving a little faster, and this would result into a new state of matter which is called the liquid. If we keep giving energy to liquid, it will change into the gaseous state. We won't worry about the plasma state for now. One of the most common examples of the different states of matter that we all are familiar with is for water. Water exists as a solid, as in ice. We all know the liquid state of water, and water can be changed into the gaseous state, which is the steam or the vapors. Phase changes occur when heat is given or taken away. Let's look at this diagram and try to understand some common terminology used for phase changes. When a solid changes into a liquid, it's called melting. So if you heat a solid, or in scientific terms, if you give energy to a solid, each particle, when gains energy, starts moving a little faster. The intermolecular distance between particles increases and the solid gets converted into a liquid. This process is called melting. The opposite of melting is called solidification. There's another term for solidification which you may know. It's called freezing. When a liquid changes into a solid, it's called freezing. How will a liquid change into a solid? If we take away heat from the liquid, which means in simple terms, if you put water into the refrigerator or into the freezer section, heat is taken away and the liquid gets converted into a solid. If we give more heat energy to the liquid, it can get converted into gaseous form, and the phase change is called evaporation. The opposite of evaporation is condensation, where a gas is getting converted into a liquid. If a solid directly changes into gaseous form, the phase change is called sublimation. Recall the example of dry ice that we discussed in class. Here are some definitions. Melting point of a solid is the temperature at which it changes state from solid to liquid. So remember, melting is the phase change in which a solid changes into a liquid. So the melting point is the temperature at which this phase change happens. Freezing point of a liquid is the temperature at which it changes state from liquid to solid. Boiling point of a liquid is the temperature at which it changes state from liquid to gas. The melting and freezing point of ice is 0 degrees Celsius. The boiling point of water is 100 degrees Celsius.